Alright, welcome to the Chapter 4 video. This one we're going to test with the webcam, see if you guys like this better or worse. Let me know in class. So for Chapter 4, we've gone through a lot of different stuff on linear equations. We've learned about point-slope form, slope-intercept form, how to graph them, how to find intercepts, and all that. So this is just going to be a summary video to kind of remind you and refresh in your mind everything we've done. So the first thing we learned about was slope, which is rise over run. And you can get that by y2 minus y1 in the numerator, divided by x2 minus x1 in the denominator. And just to remember, visually on a graph, if the slope is positive, it'll be going up and to the right. So let me change colors here. If the slope is positive, it'll be going up and to the right in this direction. So these would be positive slopes. And then if your slope is going to be negative, it has to go down and to the right. So in all cases, you're looking as you move to the right. So this is a negative slope. Any kind of slope like this is negative. And then we had two special cases. One was a vertical line and one was a horizontal line. And so those you need to pay special careful attention to. If you have a vertical line straight up and down, this one is undefined because you can't divide by 0 when you're doing your rise over run. You have a vertical rise, but you have no run. So the denominator here is 0, so that's undefined. And then a horizontal line straight sideways. This one has a slope of 0. And 0 is a totally okay slope, so there's nothing wrong with having a slope of 0. So you don't want to write undefined or no slope if the slope is actually 0. Okay? There are three forms that you can have an equation of a straight line in. The first one we learned about actually in Chapter 3 is standard form, ax plus by equals c. And here your coefficients a, b, and c had to be only integers, so positive and negative whole numbers, but no fractions or decimals. And the a term needs to be positive, so sometimes your last step would be to multiply everything by -1 to change the sign here. The second thing we learned about was slope-intercept form, y equals mx plus b. So here, x and y are your variables, m is your slope, and b is your y-intercept. So this was a nice form for graphing lines, because you could start with the y-intercept b, plot that point, and then go rise and run to get your next point. And so it would be a very convenient way to make a graph if you know the slope and the intercept. The third form that we learned about was called point-slope form. In this one, you know a coordinate point x1, y1. So this value and this value would be numbers based on a coordinate point. And of course, the same thing here with slope. So point-slope is very similar to slope-intercept. The difference is, in slope-intercept, the point that you know is the y-intercept. In point-slope form, the point that you know could be any point on the entire graph. So it's a little bit more general and allows you to make the equation without knowing a specific point. You just have to know any one point. Okay, we also learned how to find x and y intercepts. The way to find the x-intercept, so remember the x-intercept, can't write in here. The x-intercept is where your graph, or where your line, crosses the x-axis. So right there would be the x-intercept. And this point, every point along this axis, has a y value of 0, because it's on the axis, it's not above or below. So you set y equals 0 to find the x-intercept. Once you set y equals 0, you can solve the resulting equation to get the x-intercept. And likewise, to find the y-intercept, which is of course right here, every point along the y-axis, it's not gone left or right at all, so its x-coordinate is 0, because it's right on the axis. So you set the x value to 0 to get the y-intercept. And this is another way you can use to make a graph for your equations, is find the x and y-intercept, plot those 2 points, and then you can draw the line straight through. Alright, well, here we go looking at some graphs. So option 1 for graphing lines is what I just said. Find the x and y-intercepts, plot them, and draw a line. So here's our graph. You say you solve and you get this x-intercept here, and a y-intercept here, and you draw a line straight through. And again, you get those x and y-intercepts by setting the y or x coordinates to 0 and solving. Option 2, if you know a coordinate point, it could be the y-intercept or it could be any other point on the line. You can start by plotting a known point. So say I plot this known point, x1, y1. And then if I know the slope, I can do rise over run. So maybe it's a negative slope, so I go down and over, down, over, down, over. And I just keep following that same slope. And then I have whatever my line is going to be. And once you draw the line in, you can verify all positive slopes need to go up and to the right this way. all negative slopes need to go down and to the right this way. Zero slope would be a horizontal line, and a vertical slope would be none defined, or no slope would be up and down vertically. Okay, I hope. Oh no, sorry, one more thing. Parallel lines and perpendicular lines. So any two parallel lines are obviously going to have the same slope, because if they're parallel, they never cross, and if they never cross, they have to go up and over, rise over, run, the exact same amount. Perpendicular lines, these are going to cross at a right angle, and so the slope of the first one, I like to say m of the old line equals the negative reciprocal, so -1 divided by the slope of the perpendicular line. So you can switch m old and m perpendicular, same thing. The perpendicular line is 1 over the old, and the old one is -1 over the perpendicular. So negative reciprocal of each other. And then very lastly, inverse functions. This was when you did f inverse of x. You obtained this by starting with the normal equation, say y equals 2x minus 6. You switch the x and the y values, so then you'd have like x equals 2y minus 6. And then you solve for y. You add 6, you get x plus 6. Then you divide by 2, and then you write f inverse of x. So this, for example, would be the inverse function of this original. So this would be the original, and this would be the inverse. And what is the usefulness of the inverse? The inverse, it reciprocates the input and the output. So the original takes you from x to y. If you plug in the output of this function into the inverse function as the input, and then you find this f inverse, it will take you right back where you were. So it's kind of like with a mapping. You have your inputs and your outputs. The normal function takes you this way, and then the inverse takes you back the other way. So it switches the input and the output. Okay, and now that's it for Chapter 4 review. If you have any questions, of course, come by office hours or ask in class. All right, good luck.